Hey, so I am back with the last two questions to this Newton's second law mastery test walkthrough. And here we're given the mass of a car and it's asking what is the magnitude of the force required to accelerate a car of this mass by 4.75 meters per second squared. So I'll draw it out. They give us the mass of the car, and it wants A to equal 4.75 meters per second squared, okay? So all we're doing is using that equation again. Another way to write 1.7 times 10 to the third power is 1,700 kilograms times 4.75 meters per second squared. F equals 8,075 newtons. And the answers are given in scientific notations. So I suppose they want this rounded to about 8,100 newtons. And then that would be 8.1 times 10 to the third newtons. So that's F in this scenario. Yeah, so F equals ma. Really useful equation all around. And then watch out for this scientific standard notation stuff. But I think you guys, girls, should be getting the hang of that by now, hopefully. Hopefully, if not, just practice more. Or ask me for help. But lastly, number 10, yay. Isabella pushes a box of mass. So we're given M, 5.25 kilograms, write that down, with a force of 15.7 newtons. So Isabella is exerting a force of 15.7 newtons. And we can tell the object accelerates 2.50 meters per second squared. What is the force due to friction in this scenario? So we actually have to find the friction this time. So this is the most different problem we've come across so far. So first step, I suggest drawing it out. So we have this object. She's pushing 15.7 newtons in one direction, but we know there's friction pushing the other way as well. How do we know that? Well, we can double check. F equals ma. If there were no friction, then we could just divide this out and this would all equal each other. But so we'll put 15.7 newtons equals 5.25 kilograms times A. So if there were no friction, A would equal 2.99 or almost 3 meters per second squared. However, it's only going 2.5 meters per second squared. So anytime you see this not adding up, that means there's friction. Okay, so we know the net force is not just Isabella's force. There's also another force going the opposite direction. So this does not hold true. So we have to find out what is the net force. And that is honestly pretty easy too. So we're still using F equals ma. But now we need to find the net force and then subtract 15.7 from that, okay? So we're given the mass. We have the acceleration. And if you multiply that out, we have so the net force should equal 13.125. So now we can subtract 15.7 from this. And another way to write that out is to redraw it. So wham, bam, bam. That's 15.7. This will be friction, the X. So 13.125 newtons has to equal 15.7 plus X. Subtract 15.7 from each side. So minus 15.7 minus 15.7. And you get negative 2.575 newtons for X. So that means it's going in the opposite direction. And that is our friction. Negative 2.6 newtons here. Okay. So remember that process. You're given these numbers. Draw out the diagram. Since 15.7 newtons, the acceleration would be higher, but since it's only 2.5, we know friction is taking place. So we need to find the new net force and then solve for friction. Okay, this is what the net force actually is. If she's pushing 15.7 this way, what is X to make sure the net force is 13.125 newtons? Well, it's negative 2.575 or negative 2.6. Going in the opposite direction, okay? I hope that helped you out. And that is all for the second law mastery test questions. If you have any more questions, send me a message in Canvas and I will help you with this physical science stuff as much as possible. All right, that's all. And thank you guys. Bye.